Good morning, everybody. Who is there by now? Yeah. What and early bird. Tahu kau ini. Kalara. Came in the අපි අද සර්කල් පාඩම ඉවර කරන්න පුළුවන්. එතකොට ඔයගොල්ලන්ට පාස් පේපර්ස් වල ගණන් ගොඩක් කරගෙන යන්න පුළුවන් ළමයි. නිසාක්කයා. තව කවුද ඉන්නේ? ඊළඟට ඉතුරු පාඩම් මම කිව්වේ පොඩි ඒවා තියෙන්නේ දවසින් දෙකෙන් කරන ඒවා කම්ප්ලෙක්ස් නම්බර්ස් විතරක් ප්‍රශ්න තියෙනවා අපි අද කතා කරගමු ඒකට වෙනම පන්තියක් දාන්න වෙනම පන්තියක් දාන්න බලමු දැන් මේ අපිට සාමාන්‍ය විදිහට පන්ති පටන් ගන්න බැරි වෙන්නේ ළඟදී net means there right අපි පටන් ගමුද ළමයි අයිබා ළමයි ඔයගොල්ලෝ හැමෝම සුවෙන් ඇති කියලා බලාපොරොත්තු වෙනවා අපි Another we were doing a circle and we are in the last part of circle. Lakshita, Ranindu, Lihini. Okay. Good morning to you, everybody who has just connected. Right. Last day we did up to orthogonal circles. Orthogonal circles. Orthogonal circles. Do you have any question up to what we have discussed so far? Any question? Or can we start straight away with the next theorem? Ravini, Senuri, Sujata girls. Good morning to you. Right. So shall we start with the next theorem? 2001 question. Which question? 2001. Did you try this coordinate geometry? It's from what we did 2001. You mean the circle? Oh, minne na tagala balu. එහෙම නැත්නම් අද පාඩම ඉවර කරලා ඉවරලා. අද වෙලා තිබුණත් එහෙමයි නැත්නම් ඊළඟ සතියේ කරන එකද හොඳ? මොකද අද පාඩම ඉවර කරොත් ඔයගොල්ලෝ ඔක්කොම පාස් පේපර්ස් කරන්න try කරන්න. ඉස්සෙල්ලා ඉවර කරලා බලනවාද වෙලා තියෙනවද කියලා? කොහොමද කැමති? Okay, then we will do the lesson. We'll try to finish it. Then you can try all the past paper questions with today's lesson. වෙලා තිබුණොත් බලමු ළමයි මතක් කරන්න වෙලා තිබුණොත් 2001 අන්තිමට මතක් කරගන්න. Then shall we go to the next theorem? Next theorem, these are very easy now, somewhat familiar to you, right? Do you remember we did earlier in straight line, L1 equals 0, L2 equals 0 to intersecting straight lines. To intersecting straight lines, any straight line passing the common point, we said we can write in the form L1 plus lambda L2 equals 0. Okay, and homework question 5. ඒකට එමු අපි මේක පොඩ්ඩක් මතක් කරගමු, right? So any straight line passing the common point can be written in the form L1 plus lambda L2 equals 0, right? The last day, not last day, the day before, we said we have a circle and a straight line to it. Circle and a straight line, they are intersecting. Straight line and a circle intersect at they intersect at 2 points. Any circle passing these common points, circle is s equals 0, straight line is l equals 0. Any circle passing these common points can be written in the form s plus lambda l equals 0. Okay, s plus lambda l equals 0. Now you can guess what we are going to do today. The next theorem, an extension of this, and it has several parts also. Next theorem, today we are going to see, you have two circles which intersect. S1 equals 0 and S2 equals 0. Circle S1 equals 0 and another circle S2 equals 0, they intersect at say 2 points P and Q. You can guess what we are going to state here. Any circle that passes these two common points, any circle that passes these two common points can be written in the form S1 plus lambda S2 equals 0. S1 plus lambda S2 equals 0, where lambda is any real number, or lambda is a real parameter. Okay, so we can state the theorem. Before that, you want me to discuss from past papers. Question number 5 in the exercise, maybe. Right, question number 5. Given 3 circles there, S1, S2 and S1, S2 and S3. Okay, you are asked to find 2 circles. 2 circles, the conditions are, they should touch S1 externally. S1 is this x squared plus y squared plus 4x minus 10y plus 20 equals 0. So the circle or circles we are looking for should touch this externally. There's another condition. The center should lie on 3x plus the straight line 3y plus 4x minus 7 equals 0, and the other condition is r equals 2. So you have to find a circle of two circles. Anyway, the same conditions. Therefore, we will start to find one circle. So you will get the other also. එකක් පිනට හම්බ වෙනවා. එකක් හොයනකොට. හරි? Under the same conditions. මට තප්පරයක් දෙන්න ළමයි. පිළිගොඩක්. Right. These are the conditions. We'll start by assuming a general circle for what we are looking for. S4 and S5. එකක් පටන් ගමු. S4. So I like let S4 be equal to some x squared plus y squared plus 2gx plus 2fy plus c equals 0. The conditions here, the center is minus g minus f. Center of center say C. Center P equals minus g minus f. Radius is radius. I write R2. Oh, I write R1 for that. Radius R1 equals 2. Since the center lies in this straight line, so we can use that first. So that will give 3 minus f plus 4 minus g minus 7 equals 0 by 1. Substituting in 1, or it gives 3f plus 4g plus 7 equals 0. So equation number is by A. So this is equation number 1. Right? So you can derive three common equation like it's a common circle I have started with x square plus y square plus 2gx plus 2fy plus c equals 0. Okay, let me. So I have started with the general one. Now I want to find G, F, and C. The task is to find G, F, and C. You need 3 equations. You have sufficient data to get 3 equations. It touches this externally. Data number 1. Center stays on this. Data number 2, and radius is 2. Now I'm going to use this, that it touches this circle of S1. Center is say Q. Center is like minus 2 plus 5. Minus 2 plus 5. Radius, I'll write R2 is root of 4 plus 25 minus 20. So it's 3, isn't it? It is equal to 3. It's equal to 3, right? Then right. Now the condition is it touches this externally. Therefore, PQ, the distance between two centers, these two centers, PQ should be equal to R1 plus R2. Okay, PQ equals R1 plus R2. PQ is root of minus 2 plus G squared plus 5 plus F squared. So you leave it like that, and it should be equal to R1 plus R2. So R1 plus R2 is 2 plus 3. 2 plus 3 5. So finally, root of minus 2 plus G square plus 5 plus F squared equals 2 plus 3. It's 5. I'll square either side. Yeah, to get rid of the square root. So that will give G minus 2 squared plus F plus 5 squared equals 25. Simplifying this, I get no, don't simplify. Instead, equation number 2. So in this equation, we have only G and F. In equation number 1, we have only G and F as unknowns. In the second also, only G and F are the unknowns. So these two are sufficient. We don't, for the moment, we don't need to take a third equation of C. Okay, we can just solve 1 and 2. Both the equations contain only G and F, two unknowns. So what do we do? Make one subject from this and substitute. I think that's the best thing to do. Say I take F. I take F here by 1. F is equal to minus of 7 plus 4G divided by 3. Yeah, and I'll substitute it here. Substituting 1, you get like G minus 2 squared F are replaced by this. So that will be 5 minus 7 plus 4G over 3 whole thing squared equals 25. I'll expand this. G squared plus minus 4G plus 4 equals 25, not equals plus 25 minus 10 into 7 plus 4G over 3 plus 7 plus 4G over 3 squared. Equals 25. For the moment, I can at least 25. So you can do it and give me the answers for G. What are the values you get for G? Radius is 2, it's given. 5 and minus 1 are the answers. Okay, let's see. මේක අවශ්‍යයි මේ ටික ලියාගන්නකෝ එනම් විනාඩි දෙකකින්. What about the others? Agree with that means values 5 and minus 1, or you got any other answer? Agree with these answers 5 and minus 1? The others? අවශ්‍යයි ලියාගන්න මම හිත දෙන්න. Yes, says Ranindu. Okay. So if there is no objection, I'll use the values. Let me use values 5 and minus 1. Okay, the others? Equals 5 and minus 1. Equals. Answers are d equals 5, d equals minus 1. So when g equals minus 1, we can use this to find f. When g is 5, this gives f equals minus of 7 plus 20 over 3 minus g equals 5. When g is 5, you get like 27 minus 27 over 3. Kata ini dokter. I'll check with my book answers. G equals 5 or minus 1. Okay, those are the answers I have got. F is equal to, if G is 5, no, this has to be 35. No. G is 5, 20, 27 over 3. 27 over 3 is minus 9. Yeah, minus 9. Okay. Yeah. Minus 9, shall I find C at the same time? C equals root of G square plus X square minus R square. G square is 25 plus F square is 81 minus R square is 4. You have given R equals 2, right? So R square is 4. That will give you. Yeah. like root of not a nice answer, you get root of no root here. C is equal to g square plus x square minus r square, no root. So it's straight away equals 102. No square root. It's 102. When g is minus 1, from this we get f equals minus of 7 minus 4 over 3. Yeah, it's a nice answer again, minus 1. Okay, your answers are correct. G, 9 and minus 1. And C again equals e square plus x square minus r square. That will be 1 plus 1 minus 4 minus 2. Values of C 102 and minus 2. And that's what I get. Okay, now I can write down two circles, S4 and S5. කේමින්ද ටයි මේක හදන්න බැරිනේ මොනවානේ මග අරුණාද දෙතනින් එහාට දාමාරු. So now you can write down two equations, S4 and S5. ඒ ටික හදන්න ඕනද? මං හිතනවා ඔයාලට මොනවා හරි මිස්ටේක් එකක් වෙලා කියලා. රේඩියස් එක හරි හරි. දැන් මං හදන්න ඕනේ. ඒක අමාරු ගණන් නෙමෙයි. Okay, then shall we go to the next theorem? I explained it earlier. Now we have to write it formally. මේක අමාරු නෑ මෙතනින් හදා දාන්න පුළුවන්. ළමයි මේ මම කල්පනා කරා දැන් මේ අපිට තව ටික දවසක් යනකම් මේ විදිහට මේ යන්න වෙයි නේ පන්තිය සාමාන්‍ය විදිහට පටන් ගන්න කාලයක් නැති වෙයි. ඒක නිසා මට ඔයගොල්ලන්ට වැඩිපුර පන්තියක් දාන්න ඕන තියෙනවා කම්ප්ලෙක්ස් නම්බර්ස් කරගෙන යන්. කම්ප්ලෙක්ස් නම්බර්ස් ඉවරනම ඇප්ලයිඩ් පාඩමක් කරන්නත් පුළුවන්. මට ෆ්‍රී වෙලාවල් තියෙන්නේ දෙකයි. එකක් සිකුරාදා හවස අනිත් එක ඉරිදා හවස. right මෙහෙම කරන්න සිකුරාදා හවස ගත්තොත් 3:30 to 5:30 Sunday also 3:30 to 5:30 ඕගොල්ලෝ පොඩ්ඩක් ඕනනම් එක එක කතා කරගෙන මට ওই දෙකෙන් එකක් කියන්න. වැඩිම දෙනෙක්ට එක ඉන්න පුළුවන් වෙලාව. මේ සතියෙන් පටන් ගන්න පුළුවන් සිකුරාදා hari ඉරිදා hari house 3:30 to 5:30. We can start with complex numbers. If we go for මම මේ පාඩම් ඉක්මනින් කලබලෙන් කරන්නේ නැහැ. මේ පාඩම් විභාගයට තියනවා කිව්වත් ළමයි මම කිසිම පාඩමක් කලබලෙන් කරන්නේ නැහැ. හරි? මේක පේනවනේ අපි හිමින් හිමින් කරගෙන යන්නේ. ඒකට දවස් 5ක් වත්තේයි. ඊට පස්සේ ඉතුරු වෙන වෙලාවේ අපි ඇප්ලයිඩ් පාඩමක් කරන්න පුළුවන් වැඩිපුර දාන එකේ. ඕගොල්ලෝ සාකච්ඡා කරගෙන මට කියන්නකෝ සිකුරාදා හවසද වැඩි හොඳ ඉරිදා හවසද කියලා. වැඩි දෙනෙක්ට පුළුවන් දවස මම මේ සතියෙන් පටන් ගමු මේ වුණොත් මම මෙසේජ් එකක් දාන්න. either Friday 3:30 to 5:30 or Sunday 3:30 to 5:30. හරි ඕගොල්ලෝ කතා කරගන්න. කතා කරගෙන පුළුවන් තරම් කට්ටියත් එක්ක කතා කරගෙන මට දැනුම් දෙන්න. වැඩි දෙනෙක්ට පුළුවන් දවස කියන්න. එතකොට මම කරන්නම්. Okay, now we go to the next theorem. Right, theorem. I explained this earlier. Theorem, you are given two intersecting circles, s1 equals 0 and s2 equals 0. It's about a third circle that pass the common points of these two. So you can draw infinite number of other circles passing all through these two common points. So any such circle, you can guess. This is the third time we are seeing the like another version of the same theorem. So any such circle can be given written as s1 plus lambda s2 equals 0, where lambda is a real parameter, right? මේ proof එකම දෙපාරක් කරාලම ඒ නිසා මම තුන්වෙනි පාටත් ලියන්න බලාපොරොත්තු වෙන්නේ නැහැ. ඔයගොල්ලෝ තනියෙන් පුරුදු වෙන්න proof එක කරලා, right? A similar proofs we have done twice before. You do this, and today you are going to see another version of this, the fourth. ඒ දෙක ඔයගොල්ලෝ තනියම කරගන්න. හරි? Proofs ඕන ඊට පස්සේ පොතේ තියෙනවානේ proof එක. ඔයගොල්ලෝ ලියලා හරි වැරදි බලාගන්න. So the theorem says the equation of any other circle that pass the two intersecting circles, the common points of the two common points of the intersecting circles s1 and s2 can be written in the form s1 plus lambda s2 equals 0. S1 plus lambda s2 equals 0, where lambda is the real parameter, right? So we have to say where lambda is a real parameter. Right, now you have a very good practice of how to use a theorem like this, right? Some expression like this. I am not going to explain much because we have made it twice before. I straight away give examples. Proof එක තනියම කරන්න. ඉඩ තියා ගන්න ඕන වීඩියෝ එකකට. Proof, I'll give it as an exercise. You can do it. Leave about a page, and straight away I'm going to give examples. එකම දේ ආයෙ ලියන්න ඕනේ නැහැ ළමයි. Example number 1. Show that the two circles s1 equals x squared plus y squared minus 4x minus 4y plus 4 equals 0, and s2 equals x squared plus y squared minus 9 equals 0 intersect. Find the equation of the circle that pass the common points. of them, and also A 5/2, 5/2. Find the equation of the circle that pass the common point of these two circles and also the point A 5/2, 5/2. Hari, ma'am පොඩ්ඩක් වෙලා දෙනවා ළමයි. ඔක ඉක්මනින් හදලා give me the value of lambda, right? So give the value of lambda, take it down and work it out very fast. Yes, what is the value of lambda? You found it? We can't see the heading. It's theorem. Heading of theorem. Heading is theorem. Here the top line is where lambda is a real parameter. Then proof given as an exercise. I think you can see the question. Lambda equals 17. Okay, let's see. (25 over 4). 17 is 17. Yeah, looks a big value. Oh, you say 1. Okay. You say 1 and not quite sure. 1 can be correct. It's a simple answer. Take for the common denominator, W50 minus 40 minus another 40, W80 plus 16 plus lambda times, when you take for the common denominator, that will be 50 minus 36. 14 plus lambda times, 14 equals 0. I get like minus 1. Isn't it minus 1? One or minus 1? No. It's plus 1. Sorry. Plus 1. Correct. Lambda equals 1 is correct. Then I'll substitute in this. Your answer is x equals x square plus y square minus 4y plus 4 plus 1 times x square plus y square minus 9 equals 0. So it looks 2x squared plus 2y squared minus 4x. That should be minus 4x minus 4y plus 4. So that will be minus 4x minus 4y minus 9. Minus 5 equals 0. Plus 4 minus 9, yes, minus 5. Isn't it the answer? Finally. So I'll add another part to that question. Find the equation of the smaller circle. That passes the common points of no. Sorry, not now. I'll give it later. I have to explain something before that. Not now. I'll give it after the next thing, not the theorem. We are going to extend this theorem and there are a few more results. මේක හරිනම් අපි එතනට යන්න ළමයි. Right. Next is the common code. Common code. Right now, it's like something we derived from the previous result. So we have two circles, S1 equals 0 and S2 equals 0. Right? S1 equals 0 and S2 equals 0. If they intersect, then S1 plus lambda S2 equals 0 represents a circle, some circle that pass the common points. Obviously, S1 plus S1 plus lambda S2 equals any circle passing these 2 points can be written in this form, right? But we didn't say anything written in this form represents a circle that pass these 2 points. We just said any circle that pass the common points can be represented by this form, right? In this form, but we didn't say that anything written in this form represents a circle that pass the common points. The first condition, the circles should be intersecting. And there's another one. For a moment, take the two circles. Consider two circles. S1 equals x squared plus leaving. So we are writing in the standard form the two circles, x squared plus y squared plus 2gx plus 2fy plus 2g1x 2f1y plus c1 equals 0. The first circle, x squared plus y squared plus 2g1x plus 2f1y plus c1 equals 0. And the second is x squared plus y squared plus 2g2x plus 2f2y plus c2 equals 0. Okay. Now consider s1 plus lambda s2. Suppose that they intersect. Two intersecting circles. Two intersecting circles, right? Now consider this equation. S1 plus lambda s2 equals 0. Earlier we wrote circles passing the common points in this form in the previous question also, right? But what if lambda is equal to -1? What if lambda is equal to -1? The two circles intersect each other. Now consider two circles are given in this form, the standard form, x squared plus y squared plus 2g1x plus 2f1y plus c1 equals 0, x squared plus y squared plus 2g2x plus 2f2y plus c2 equals 0. Two circles are given in the standard form, they intersect each other, right? Earlier we have seen, earlier we have written a circle passing the common points in the form s1 plus lambda s2 equals 0. Now my question, what if lambda is equal to -1? Yeah. Yeah, let me say it's a straight line. Yes. If lambda equals -1, so that will be equal to s1 minus s2 equals 0. Will that be a circle anymore? S1 minus s2 equals 0. You see that x square and y square terms disappear, leaving a linear equation of x and y. It's a straight line. Yes, correct. So what is that answer is correct. It's a straight line. Okay, it's accepted. And the second question, what is this straight line? Two circles intersect. Two circles intersect. You said S1 minus S2 equals 0 represents a straight line. So what is the property of that straight line? Is the question. What is the property? As same as in the previous theorem, it should pass the common points of these two circles. That straight line should pass the common points. Common chord. මොකද්ද මේ යන්නේ topic එකේ common chord topic එක common chord නේද? yeah, it is the common chord. Topic එක නිසා අර කියන්නේ. Yes, it has to be the, it's a straight line. It's a straight line. Moreover, it should pass these common points. If it passes the common points, then it has to be the common chord. The chord common to the two circles, right? That passes the common points. So this common chord is given by S1 minus S2 equals 0. So that's the theorem. If two circles intersect, and if they are given in the standard form, if the first circle is given like අපි කලින් එකේ අන්තිම උත්තරේ ලිව්වේ in the last example, we wrote like 2x square plus 2y square plus something, and S2 is given in this form, then S1 minus S2 equals 0. If this is like 2x square plus 2y square plus something, and this is given as x square plus y square plus something, then you write S1 minus S2 equals 0. Then here x square terms and y square terms will remain. That will represent another circle, right? Another circle. But if the circles are given in this form, we can coefficients samanana. The coefficients of x square and y square are equal into two circles, right? Two circles. Then S1 minus S2 equals 0. We have no x square terms, y no square terms. So it will give a straight line. Okay. So that straight line is the common chord. So two conditions: two circles should intersect each other, and the equation should be given in this standard form. Then S1 minus S2 equals 0 gives the common chord. Common chord. And there's another extension of this. What if okay, what if the two circles are in contact, maybe externally, maybe internally, they touch each other. If two circles are in contact, like this, there is one common point. Intersect. They intersect means they have two common points. They are in contact means they have a single common point, right? S1 equals 0, S2 equals 0, S1 equals 0, S2 equals 0, no two common points, there is only one. Then this S1 minus S2 equals 0 is a straight line. What is the straight line? If they are in contact, maybe externally or internally, they can even be in contact internally. In this case, S1 minus S2 equals 0 represents what? Common tangent. Yeah, it represents the common tangent to two circles. Yes. Like this. And here also S1 minus S2 equals 0. So if they are in contact, S1 minus and again the circles are given in the standard form, then S1 minus S2 equals 0 represents the common tangent to them, sorry, common tangent of two circles, right? In contact, then if the about two circles are in contact, then S1 minus S2 equals 0 represents the common tangent. හරි. ඔය ටික තේරුණා නේද ළමයි? ඔක ලියා ගන්නකො අපි ගානක් දෙයක් හදමු. තව එක දෙයක් තියෙන ඉගෙන ගන්න මේ පාඩමේ. මේකට ගානක් දෙයක් හදමු. තව එක දෙයක් තියෙනවා. මේ ප්‍රූෆ්ස් ඔක්කොම ඔයගොල්ලන්ට කරන්න පුළුවන් කලින් විදියමයි. දැන් එක ප්‍රූෆ් එක නැත්නම් අපිට 6 පාරක් ලියන්න වෙනවා. මේ දෙපාරක් කරා. ඊට පස්සේ තව ඉස්සෙල් s1 lambda s2 0 3යි 4යි 5යි. මේකට ලියන්න ඕනේ. පස් පාරක් ලියන්න වෙන එක ප්‍රූෆ් එක නැත්නම් ඔයගොල්ලෝ ඉතුරු ටික කරගන්න. හරි? අපි දෙකක් කරා. ඔයගොල්ලෝ तुम्ही ग्रामर हे करता ටික ලියන්නද ළමයි? ටික ගානක් දෙයක් හදමු. We can go back to the previous example. The previous question and the previous theorem. So the question is find the equation of the smallest circle. Find the equation of the common chord. Common chord of the two circles given in previous example. Find also the equation of the smallest circle, of the smallest circle that passes the common points of them. හරි බලන්න මේක කරන්න. Yeah. Find the equation of the common chord of the two circles given in the previous example. Find also the equation of the smallest circle that passes the common points of the two circles. බලන්න ළමයි කරන්න. The common chord given by S1 minus S2 equals 0. The two circles given in the previous example. So the two circles are S1 equals minus 4x minus 4y plus 4 equals 0. S2 equals x squared plus y squared minus 9 equals 0. And in the last example, we have shown that they intersect, right? These two are two intersecting circles. So the common chord is given by S1 minus S2 equals 0. Subtract them, W minus 4x minus 4y plus 13 equals 0. So I multiply them by minus 1. 4x plus 4y minus 13 equals 0. That's the common chord. Okay, now you can answer the second part. To find the smaller circle. Remember? Right. How to find the smallest circle? Smaller circle. So you are asked to find a circle that passes through common points. These two common points. Okay. If it passes these 2 points P and Q, if you want, you can draw it separately even. I'll do it separately. You are given 2 points. Right? Forget this diagram, the complicate one. Just take 2 points. You are asked to find the smallest circle that can pass these two common points. What is the requirement? To be the smallest circle passing these 2 points. Can there be you just join them? So you can't draw a circle like this. For the smaller circle, this PQ has to be a diameter. For the smaller circle, PQ has to be a diameter. For the smaller circle, PQ has to be a diameter. Yeah. Yes. Right. So the center should lie on that PQ diameter, PQ chord. Got that? Right? Yes, sir. So you take 2 points and you are asked to find. You are given 2 points and asked to draw the smaller circle that pass the 2 common points. So it has to be the circle with PQ as a diameter. Ita very podi ekak tanina bෑ. Okay. Okay. Now coming back to this. For the smaller circle, PQ has to be a diameter, or the center of the smaller circle should lie in this common chord, right? The center. If the center is R, it should lie in this common chord. So that is the requirement, right? So we will write you are asked to find a circle which passes the common points. So you can start it as S1 plus lambda S2 equals 0. Smaller circle. So you start by writing S1 plus lambda S2 equals 0. S1 is this, S2 is this. Plus lambda times x square plus y square minus 9 equals 0. Right? So we can express the circle in this form because it passes the common points. Right? And the center of this should lie in this common chord. So that is the requirement for this to be the smallest circle. First, we will find the center of this in terms of lambda, for which we will simplify it. X square taken out 1 plus lambda, y square taken out 1 plus lambda plus minus 4x minus 4y, and the constant term is 4 minus 9 lambda equals 0. Right? So you have to divide by 1 plus lambda, x square plus y square. I'll write this as minus 2 times 2 over 1 plus lambda plus 2 times minus 2 over 1 plus lambda x plus 2 times this I'll write as minus 2 over 1 plus lambda y plus 4 minus 9 lambda over 1 plus lambda equals 0. Right? Now you can easily identify G and F. So this is G and this is F. And the center is minus G minus F. Center is minus G minus F. So it has to be 2 over 1 plus lambda and 2 over 1 plus lambda. So we found the center, writing the circle in the form S1 plus lambda S2 equals 0. Now our argument is this center should lie in this common chord. කවුද සවිරු තේරුණා නේද? එදා අහලා තිබුණා එක තේරුන්නේ නැහැ කියලා. අද තේරුණාද කාරණේ? Center of the the smaller circle. Center of the smaller circle lies in the common chord. Lies in the common chord, this one. 4x plus 4y minus 13 equals 0. You can use the fact to find lambda. So 4 times 2 over 1 plus lambda plus 4 times 2 over 1 plus lambda minus 13 equals 0. I multiply it by 1 plus lambda. 8 plus minus 13 times 1 plus lambda equals 0. Okay. It looks like lambda is equal to 3 over 13. Lambda is 3 over 13. Agree? This value for lambda? Yes, okay. Then substitute it back here and you can complete your answer. Lambda value, substituting this. I name it number 1. I name this equation number 1. Substitute in 1. You get x squared plus y squared minus 4x minus 4y plus 4. Lambda is plus 3 over 13. X square plus y square minus 9 equals 0. That will be 13x square minus 3x square. 10x squared, 13y square minus 3y square plus 13y squared minus 52 minus 52y minus 52x minus 52y and 26, 52, 52 minus 27, that will be 25. 52 minus 27, yeah, plus 25 equals 0. And finally, this is the answer. Yeah, this is the answer. Thirteen into 2, not 4. 13 into 2gx. Coefficients of x and y should be 16. Oh. It should be 10. No, 13 and 13. You agree with lambda, right? Lambda equals 3 over 13. I substitute it here. Yeah, these should be x square terms. Yeah, should be 16. 13 plus 3 should be 16. Not x square, not x square terms should be 16. Yes. Okay, I agree. 16. Hi. So like we have covered all the theorems given in this, but there is okay, Nisarka agency. It's 16. I agree. I have corrected it. Okay. Uh, and one more thing, not a theorem, again some method, right? We have to do some method to find what you call the common tangents to two circles. Given two circles, common tangents from an external point. I'll explain it. Not a theorem. Just need to know how to find, right? How to work out a given problem like this. Right. Common tangents. Common tangents. You can see it here. I'll write it below. Common tangents to two circles from external points. Common tangents to two circles from an external point. I'll draw and explain it. You are given two circles. So given two circles S1 and S2. There are two cases, right? Two cases. Given two circles S1, S2 of centers P and Q. So you can find a point in between them, or between the two centers, through which you can draw two tangents common to both the circles, right? It goes like this. So you can find some point R. You can find some point R through which you can draw two common tangents to two circles. The circles are not in contact, okay? They are externally, external circles. But here the point R lies in between P and Q. This is the first case from a point which lies in between the two centers. R lies in between S1 and S2, right? And there is another possibility. There's another possibility. You are given two circles. You are given two circles S1 and S2. So sometimes you can find a point here. In this, the point R lies internally to P and Q. It divides PQ internally to a positive ratio, right? Or in a case like this, you can find even a point even outside, external to the centers P and Q, a point R on one side of the two circles, right? Uh, like this, it is this point through which you draw these two tangents common to the two circles, right? So R lies on one side, or R lies externally in the line PQ, externally. Okay, the thing is this, sometimes they ask a question, friends, sometimes they ask a question, they give equations of two circles and ask to find this point, or maybe this point, and then the two, of course, the two tangents, or even without asking the point, they can ask equations of these two tangents, these two, or maybe these two, right? The thing is, you should know when given equations of two circles S1 and S2, S1 and S2, you should know how to find these two tangents. The thing is this, at the very beginning, now remember now, at the very beginning, we learned if you are given a circle and a point outside, maybe this circle or this circle, you can take one of them, you are given equation of a circle and a point outside, we learned how to, at the very beginning we did this, how to find equations of two tangents, right? If you know the equation of the circle, if you know the point of R, then you can easily find the two tangents. So that means what is new for the moment is to find coordinates of R. If you can find the coordinates of R, if you have the coordinates of this point R, then you can easily find equations of these two tangents using our previous methods. So here also it's the same, right? You can use either equation of S1 or S2 to find these two equations if you know the coordinates of point R, right? So what we need to know, what we need to learn new here is how to find coordinates of R in that case, so in this case, right? So that's the only thing to do, how to find coordinates of point R. They are all here. So we can discuss it. So we can discuss it now, how to find a common point R. එහෙම නැත්නම් දැන් ඔක ලියා ගන්න ළමයි. ඔක ලියා ගන්න මම ආපහු රූපය අඳලා ආයෙ විස්තර කරන්න. These are the two tangents, common tangents. I'll write a sentence here. If we know, if we find the coordinates of if we can find coordinates of the point R, are the circles equal? No, not necessarily in any of these. If the circles are equal, especially here, you can't find a point R, right? If the circles are equal in size, equal in radius, here there can be any two circles. මගේ රූපේ වෙන්නේ වගේද? ඔය එක ලොකු නේද? P and Q, the centers of two circles. P, Q are centers of two circles. P, Q, like given, you are given the equation of x1, x2, you can easily find it. If you find coordinates of R, then we can use PQ are always a straight line. Yes. You join P and Q. R should stay on that. Again, come galon due to symmetry. May try up down top what improve may penny. Due to symmetry, the R should lie in the line joining P and Q. Yeah. Then we can use the equation of x1 over x2 to find the equations of two common tangents. Okay. So now the task is to find the point R in each of these. Yeah, in each of these cases. How to find coordinates of R. when we get two values for GF in the fifth question, we did before defining the equation specified. So yes. So in this case, in that question number 5 that we did at the beginning, yes, S4 S5 you can decide. ඒක වෙනසක් නැහැ නේද ළමයි? S4 S5 වාට කැමති නමක් දාගන්න take as S4 or take the other as S5. ඒක ප්‍රශ්නයක් නැහැ. කොහොම වුණත් වෙනසක් වෙන්නේ නැහැ. No problem. Specified. But in the second part, in the second part, let's see. මම දැන් ආයි බලන්න ඕන question එක. In the second part there is something I remember. In the second part, it's specified. Of S4, the center should be in the first quadrant. එතකොට කැමති විදිහකට ගන්න බෑ. S4 should be center of S4 should be in the first quadrant. Now check the two centers. Check the two centers of the two circles that we get. Take the circle with the center in the first quadrant as S4. In the other is automatically S5. Sorry, මම දැන් I කියපු ප්‍රශ්නේ. හරි. සාමාන්‍ය නම් අපිට කැමති විදිහට ගන්න පුළුවන්, but here it is specified. In the question, given the first quadrant, okay? Center of S4 should be in the first quadrant. Right. Now back to this. We want to find coordinates of R. You are given equation of S1 and also equation of S2. So you know coordinates of the center P, you know the coordinates of the center Q. You can find the radii R1 and R2. So P has a coordinate minus G1 minus F1. Say Q has coordinates minus G2 minus F2. Two centers. And the radii, before marking the radii, let's join this. Join this, and then I'll lay a normal from this center to this tangent. I drew the normal from the center to this tangent, and to the other one, I'll draw it the other way, the opposite side. I'll name these points P, Q, R, S, and T. S and T, right? Now look at this. Say the radii are R1 and R2. Radii of two circles are R1 and R2. Okay. Of the circle S1, you are given the equations. You can find the center is minus V1 minus F1, and the radius R1. Radius is R1. Of the circle S2, you are given the equation. You can find the center minus G2 minus F2, and the radius is R2, right? Now look at these two triangles. These two triangles, P PRT and RQS. These two triangles. PRT and QRS. Any comment on these two triangles? What do you say? The triangles. What do you see? They are equiangular, or we say similar. Similar triangles. The triangles PRT and PQS are or I'll say similar. Therefore, PR over RQ, PR over RQ equals PT over, or I'll just write R1 over R2, R1 over R2, right? So now we have coordinates of P and coordinates of Q, and we also have this ratio into which R divides PQ. Oh, I draw it again. It looks like we have coordinates of P minus G1 minus F1. We have coordinates of Q, the other center, minus G2 minus F2. And the point that we need to find is R, which divides this ratio, this line segment PQ, to the ratio R1 is to R2. Note that R stays internally. Now, can't you find the coordinates of R very easily? We use to find R. We have these two coordinates of these 2 points, and also we have the ratio. Now, you can easily use the ratio theorem to find R. So, by ratio theorem, R has coordinates R2 into minus G minus G1 rather, plus R1 into minus G2 divided by R1 plus R2. Similarly, y coordinate R2 into minus F1 plus R1 into minus F2 divided by R1 plus R2. So, you can easily find coordinates of this point R, and after that you can use equation of S1 or equation of S2 to find these two equations of these two tangents. Right? Right. Oh, if the other case, how to find coordinates of R? Extension and the other one is this. Right, this is the second case. Is one circle, is two circle. This has coordinate center P minus G1 minus F1, and the other coordinates of the center Q minus G2 minus F2. Right. Right, and the radii. So I'll first join them, the two centers, and they will extend to R. That line will extend to R. Right now, I'll lay the two or draw the two normals from one from the center of P, center of S1 to the tangent, say PQ R is there, say S with the circle S1, right? Then to the other one, I'll draw in the same direction. It will be a parallel line. Say this is the point T. And take the two radii as R1 and R2. Okay, now very much similar to the previous one, you take these two triangles PRS and QRT. PRS and QRT, the two triangles are similar. From similar triangles, PRS and QRT. So here we say PR over QR. PR over QR equals R1 over R2. The difference between this and this is here R stays in between P and Q. It divides internally. In this R divides the PQ ratio externally. මට මෙතන ඉඩමදි ළමයි අපි ඊළඟ ටික ලියා ගමු. දැන් ඔයගොල්ලෝ උතන ගණන් කරන්න පොඩි වෙනසක් තියෙන්නේ. Here R is a point which divides the line PQ externally. The ratio theorem we use the other way around, right, for a external point. හරි එතන යනකම් මේ ටික ලියා ගන්නකො. ඊට පස්සේ බලමු. ඔක ලියාගත්තා නම් අපි එක්සැම්පල් එකට යන්න ළමයි. මේක අමාරු දෙයක් නෙමෙයි. අපි එක එක්සැම්පල් එක නිකන් කරමු. ඔයගොල්ලන්ට මේ ඔක ලේසියෙන් අල්ලගන්න පුළුවන්. මේක ඉවර කරන්න එපා නේ. You first finish this. First finish this. If you draw, look like R is the unknown. You have P minus G1 minus F1 and Q minus G2 minus F2. We have the ratio R stays are externally to PQ, therefore the ratio we will write as a negative ratio. R1 is to or minus R1 is to R2. Now, using the ratio theorem, you can get the coordinates of R. R2 into minus minus G2 into minus R1. So that will be R1 G2 minus R2 G1 divided by R1 minus R2. Okay. Similarly, y coordinate R1 F2 minus R2 F1 over R1 minus R2. So using ratio theorem, you can find coordinates of R. Knowing coordinates of R and equation of S1 over S2, you can find the two tangents. Okay. Right, we go to an example. Example, find equations of up to common tangents from an external point. External point to two circles. Two circles are S1 equals x squared plus y squared plus 2x plus 4y plus 1 equals 0. S2 equals x squared plus y squared minus 6x minus 8y plus 9 equals 0. ඔන්න ප්‍රශ්නේ ඔයගොල්ලෝ නිකන් පටන් ගන්න කරගෙන යන්න. ඊට කලින් බලමු අපි එහෙනම් ඔයගොල්ලෝ සිකුරාදා ප්‍රශ්නයක් නැහැ කියනවා නේද? මේ අපිට පටන් ගන්න complex numbers the extra class. එහෙනම් මේ සතියේ නම් සිකුරාදා හවස 3:00 ප්‍රශ්නයක් නැහැ නේ ළමයි? සිකුරාදා එහෙනම් ටිකක් පරක් වෙලා පටන් ගමු. තව පන්තියක් තියෙනවා. සිකුරාදා හවස 5ට විතර පටන් ගමු. 5 ඉඳන් 7ට. ප්‍රශ්නයක් නැහැ නේද? 5 to 7, Friday 5 to 7. There is another class here till around 4. කෝකටත් අපි 5 to 7 දාගමු. After 5. Right. At 5, will it be okay? At 5 to 7. Okay. And now Friday 5 to 7. Friday 5 to 7. We start complex numbers Friday at 5. මේ සතියේ නම් පටන් ගමු. හරි. දැන් මේකට පොඩ්ඩක් පටන් ගන්න ළමයි just find coordinates of path ටක් ගාලා හොයලා කියන්න coordinates of path. Okay, first find coordinates of path. Draw it roughly and find coordinates of path. Center of this -1 -2. මෙයාගේ ratio මොකද වෙන්නේ? The ratio of this 4 plus 1 minus 1. It's 1. Radius is 1. මෙයාගේ center is 3 and 4. Radius is 4. මෙයාගේ radius එක 4 නේ. 1 and 4. Am I correct? මෙයාගේ දෙක නේ 2 and 4. Radia 2 and 4. Yeah. So it looks like the ratio is 1:2. 1:2. Minus 1:2. Since it divides externally, it has -1 and -2 the coordinates. This has 3 and 4. Are අකල හොයලා කියන්නේ coordinates of r minus 4 plus 4 over minus 1 plus 2 minus 3 minus 2 over then minus 4 minus 4 minus 4 minus 4 minus 4 එතකොට එන්නේ මොනවාද 5 and 8 කවුරුහරි හෙවද ළමයි 5 and 8 no නිසක්යා agency my answer is 5 and 8 බලන්න externally බෙදෙන්නේ external ratio did you use it correctly check it my answer is minus 5 and minus 8 5 and 8 oh minus 5 and minus 8 minus 5 minus 8 I got Rashin බලන්න check කරන්න minus 5 minus Rashin I බලන්න my answer is minus 5 minus 8 not plus right so we can use one of the circles with this point r I'll take this one I'll take this one and the point r to find the equations of these two tangents so essentially 1 and minus 2 radius is 2 මතකද මෙයා මුලදී ඉගෙන ගත්තා මුලදී ඉගෙන ගත්ත මතකනේ you are given a point and a circle how to find these two tangents so you start by assuming some straight line some equation y equals mx plus c we need to find m and c right you can get one equation very easily if the tangent passes this point අපි එකක් හොයමු උතර පිනට අනිත් එකක් හම්බ වෙනවා right let's one tangent b y equals mx plus c මේක නිකම් පොඩ බලාගන්න නැතිලම එතකොට කරන්න පුළුවන් it passes r you substitute this point minus 8 equals minus 5m plus c so you get like c equals 5m minus 8 that gives an equation and we need the second equation for which we can use sound එක ඇහෙන්නේ දැන් ඇහෙනවද ළමයි? දැන් ඇහෙනවද? හරිනේ? ඕකේ. හරි. So we got one equation using this point, this tangent passes this point. We substitute with it, and this equation, to get the other, we need another. දැන් හරි නේද? දැන් හරිනේ. මම මේක හදනකොට පොඩ්ඩක් වයර් එකක් ඩිස්කනෙක්ට් කළා. දැන් හරි ඇතිනේ? තාම නැද්ද? පොඩ්ඩක් ඉන්න. චුටි පුතේ අයියට පොඩ්ඩක් එන්න කියන්නේ. මෙතන මේකද? දැන් හරිද? නෑ සවුන්ඩ්ස් ප්‍රශ්නයක්. මම මෙතන ෂොට් වුණා. දැන් හරි වගේ. දැන් හරි නේද ළමයි? දැන් ඇහෙනවනේ? ඔව් හරි. පොඩ වයර් ෂොට් වුණා ඒක. How to get the other equation for which we can use this line has to be tangent to this circle. අපි එක පාවිච්චි කරන්න පුළුවන්. This distance from center P, the normal distance to the line is equal to 2. Since the line is a tangent, P minus 1 minus 2, and the line I will write in the form mx minus y plus equals 0. Mx minus y plus equals 0, and normal distance is equal to the radius. This normal, the length is equal to radius 2. So you get like mod of, substitute this point in this, mx is this, minus m, y is this, minus plus 2 plus c divided by root of m square plus 1. Root of m square plus 1 is equal to 2. හරි ඔත් ඉතුරු ටික කරගන්න ළමයි. ඔයගලන්ට පුළුවන් ඉතුරු ටික කරගන්න. For C you can substitute from this equation and solve it. ඕව අපි කලින් කරලා තියෙනවා. අනික මතක් කරා. You will get two values for m when you get rid of the modulus. You will get two values for m. So that will give two equations, two tangents. හරි. එහෙනම් ඔක තනියම හදන්න. basically පාඩම ඉවරයි ළමයි. පාඩම විතර නෙමෙයි අපි coordinate geometry ඉවරයි. අපි trig ඉවර කරලා ඉතින් බොහෝ මොනවාද කාලයකට පෙර. ඊට පස්සේ calculus ඉවර කරා දෙසැම්බර් වගේ වෙනකොට ජනවාරි. ඔන්න දැන් coordinate geometry ඉවරයි. අපිට algebra පාඩම් ටිකක් තියෙන්නේ. ලබන සතියේ මෙහෙම කරමු. ඕගොල්ලෝ මේකේ අන්තිම exercise එක තියෙනවනේ එදා පටන් ගත්තේ. ඒක ඉවර කරන්න ඉස්සෙල්ලා. මේ ගණක් හදලා ඉවර කරන්න. page 235 මේක exercise එක ඉවර කරන්න. ඊට පස්සේ 2011 නම් ගණන් ටික හදන්න. හදන්න මොන හරි අමාරු ඒවා අදත් ඇහුවනේ 2011 ද sorry 2011 නෙමෙයි 2000 ඉඳගෙන ගණන් ටික හදන්න. මට වැරදුනා. 2000 ඉඳන් දැන් හදන්න. අමාරුව තියෙනවා නම් ඊළඟ සතියේ ඩිස්කස් කරමු. ඊට පස්සේ අලුත් පාඩම ඇල්ජිබ්‍රා පාඩම් විතරයි ඉතුරු. ඉන්ඩක්ෂන් අපිට දවසින් ඉවර කරන්න පුළුවන්. මේ පන්තිය පටන් ගමු. ඉන්ඩක්ෂන් දවසින් ඉවරයි. සීරීස් දවසක් හෝ දෙකක්. ඊට පස්සේ පර්මිටේෂන් ඊට පස්සේ බයිනෝමියල් දවස් දෙකකින් වගේ ඉවරයි. පර්මිටේෂන් ඇන්ඩ් කම්බිනේෂන්ස් දවස් දෙකකින් ඉවරයි. ඒකට සිලබස් එක ඉවරයි. අනිත් පන්තිය වෙනම සිකුරාදාට කරනවා මොනවද? අනේ එක ගානක් තියෙනවානේ. question number 13 නේද? ඔව්. මොනවද? complex numbers කරලා matrices පොඩ්ඩයි තියෙන්නේ. ඒ දෙකම එකේ කරමු. ඒතර pure syllabus එක ඉවරයි. ඉවරුනම් පස්සේ ඉතුරු වෙන දවස් අපි Friday ඉතුරු වෙන කාලේ අපි ගමු මේ අපේ වැඩිපුර පන්තියට මේ applied maths කරන්න. හරි? බලමු දැන් මේ තියෙන තත්ත්වය වෙනස් වුණොත් plan වෙනස් වෙයි. හරි? එහෙමනම් අදට පන්තිය උතනින් නවත්තමු. ඒතර coordinate geometry ඉවරයි. ඒ තියෙන ගණන් ඔක්කොම දැන්ට අපි ඉවර කරපු නිසා past papers ඔයගොල්ලන්ට කරගෙන යන්න පුළුවන්. අර algebra ගණන් දෙකකට විතරයි අපිට ඉගෙන ගන්න තියෙන්නේ. හරි? අනිත් ඔක්කොම කරලා තියෙන්නේ. ඔයගොල්ලෝ කරගෙන යන්න. මේ algebra පාඩම් ටික බොහොම ලේසි. complex numbers විතරයි ටික ලොකු එකකට තියෙන්නේ. පොඩි පාඩම් ඉතුරු. මම දැන් කිව්වාගේ induction එක දවසින් ඉවරයි. series දවස් දෙකක් යන්නේ නැහැ. binomial එකට දවස් දෙකක් යයි. permutation combination දවස් දෙකක් හොඳටම ඇති. පොඩි පාඩම් ඉතුරු ළමයි. ඒකෙන් තමයි අර 12 13 ප්‍රශ්න ටික දෙක අහන්නේ. ඒක අතල්ලා හරි දැන් පාස් පේපර්ස් කැමති කෙනෙක් කරන්න. නැත්තම් තව මාසයක් ඉන්න පාස් පේපර්ස් කරන්න ලොකු අදිසියක් නැහැ. හරි. වැඩ කරගෙන යන්න මම දෙමෝපිය ඔයගොල්ලෝගේ කීප දෙනෙක් කතා කරා. අම්මලා තාත්තලා කියන්නේ ළමයි වැඩ කරනවා කියලා. ඒක හොඳයි මට සතුටුයි ඒ ගැන. කම්මැලි නැතුව කරගෙන යන්න. ඔයගොල්ලන්ට අර තනියම ඉන්න කම්මැලිලාට මම කිව්වනේ චිත්‍ර අඳින්න, නටන්න ඕන නම් නටන්න, සින්දු කියන්න, ප්ලේ කරනවා, මියුසික් ප්ලේ කරන්න, ඕන දෙයක් කරන්න. ඒව කළා ඔයගොල්ලෝගේ අර ටිකක් මනස සංසුන්ව තියාගන්න, ටිකක් භාවනා කරන්න. ඒවත් කරලා වැඩ කරගෙන යන්න. වැඩි දෙනෙක් වැඩ කරනවා කියලා මම දන්නවා. හරි. එහෙනම් බොහොම හොඳයි. ඒ විදිහට කරගෙන යන්න. එහෙනම් සිකුරාදා. නෑ අපි හෙට පන්තිය තියෙනවා නේ. හෙට ඇප්ලයිඩ් පන්තිය. right. එහෙනම් හෙට උදේට පන්තිය හම්බ වෙනවා. බුදු සරණයි හැමෝටම නිරෝගී සුවය ප්‍රාර්ථනා කරනවා.